Hello, everyone. We'll do the recap and then we'll continue from where we left for object oriented programming in Java. Just one second. I'm not on mute. Hi, Sajjan. How are you?
Yeah, I'm fine.
Good. So we'll start with the object and class. This is a question in the paper, also last year's paper, as well as in the assignment. So object is basically a real world entity that can be distinctly identified. Uh, Object is an instance of a class and its properties and methods. A class is a template or blueprint that you can use to create objects, and it has data member and data methods. So data fields are called member data or instance variables, and methods are called member functions. Sajjan, would you like to keep yourself on mute?
Sure.
Thank you. So, what are the advantages of member data and member functions within the class? It helps us get the encapsulation, which means that the data doesn't get leaked out of the class. So they are kept inside the class to restrict their access from outside of the class to avoid accidental modification. Data hiding is ensured by keeping the data inside the class, so it helps in data hiding. The definition of the member functions or methods inside the class provides the scope of the modification in the definition of the method without affecting the outside world. So whatever changes you make inside the class, it's not going to affect the outside the world. So that is one of the advantages of member data and member functions. What care should be taken in object-oriented programming? So because when an object is created, it's created as a reference of another object. If you make a change in one object, the data members, the values of the data members of the other object can also change. And that's why you should be careful when making those change. So in Java, one object can be used as a reference to another object of the same type. When objects are used as a reference, one should take care while performing operations on the objects, because if there's a change, any change, data member values of one object, values of the respective data members of a second object also get changed. Okay, how is an object created? It's created in two steps. First, we declare the object, and then second is we instantiate it. During the declaration, we basically put the name of the variable prefixed by the name of the class. So in this case, student and student1, we declare where the reference to the object is created, but the memory is not allocated. And the first step, but in second step, the when you use the new keyword, the class name with the curly brace with the round brackets, and assign it to whatever object you've created, then this is the point when the memory is allocated. You can also combine these into one, like so. So declaration, a variable is declared with variable name and object type, and instantiation where allocation of the memory is done using the new operator. Okay, so first only a reference to the variable is created, and at this stage no actual object exists. When the new operator is used, the memory is then allocated for the actual existence of the object. The new operator in Java is used to dynamically allocate the memory for an object. It returns a reference to the object and also binds the reference with the object. What are the difference between classes and objects? So objects have properties and methods, and classes define those properties and methods. So classes describe the behavior and state of the object. For example, cars, dogs, humans, etc. are objects of a class species. A dog object of a class species can have its state, like name, breed, color, and it can have behavior or method, which is running or barking or wagging a tail. Okay, so objects have states and behaviors, and class describes these states and behaviors. What is data hiding and how it is achieved? So data hiding means that we're hiding the detailed information and just showing the essential information to the user. User shouldn't be worried about how the thing is done. He should just focus on what the thing is done. So it enables the developers to protect the data and hide the implementation details from outside interference. To implement the data hiding, variables in a class should have private access modifier. So if you want to hide a particular variable and you don't want the child classes to access those variables, you can declare that as private. So when someone needs to access or modify the private variable from outside the class, they can use the getters and setters, get method and set method. What are getters and setters? So in case if there is a variable that's declared private in a class, a child class cannot really access that. If you want to change its value or get its value, then we can use a get method and a set method. The job of the get method is to get the value of that private variable, and the set method can set the value of the variable depending on what value is passed as a parameter. So private variables can only be accessed within the same class. However, it is possible to access them if we provide the public get and set methods. So this is an example of a program. We have a class called person. There's a private variable called name with a type string. If you try to access it by using .name, we get an error. If we try to modify it using .name, we get an error. But if we use get name and set name, which is getters and setters, we can access it using get name. So this is going to return that particular variable into the child class, or the class that's creating an object. So we can access that. And then we can set its value using set name and then pass the value of it. So the setter will be able to set the value of that. Okay, abstraction and using abstract class. Data abstraction is the process of hiding the detailed information and only presenting the essential information to the user. For example, a car can be viewed as a car rather than its individual components. In Java programming, abstraction can be achieved by using abstract class or interfaces. Any user can use a method without knowing about the implementation details. So it's basically hiding the implementation details and only showing the essential information. For example, here the method body is hidden from the user. When we use system.out.println on the method to display the string, we do not bother about how it is implemented. For example, sending SMS where you type the text and send the message, you don't know the internal processing about the message delivery. Abstraction lets you focus on what the object does instead of how it does it. So to sum up, it focuses on what, then how. Okay, let's talk about abstract class. Abstract classes are those classes which have a keyword as abstract. They can be extended, but they cannot be instantiated, so you can't create an object out of it. If there's any child class that basically extends that abstract class, it must implement all of its methods. It can have abstract and non-abstract methods. It can have constructors and static methods also. It can have final methods which will force the subclass not to change the body of the method. Encapsulation is binding the data members and the methods together. It is done securely by making the data field accessible only to class members by declaring the data fields as private. Everyone outside of the class knows how to access and use the methods without thinking about the implementation details. So encapsulation is basically binding the data members, which are the variables, and the methods together. In Java, setter and getter methods are used to ensure the read-only or write-only operations. Now I talk about inheritance. Inheritance is where one class inherits the properties and methods of another class. And it is the process by which one object acquires the property of another object. It allows for a creation of a new class similar to the previously defined class and the new class can have its own data members and methods. This feature of Java supports concept of hierarchical classification. So the parent class is also called superclass. The children are called subclasses. What are the advantages of inheritance? Well, it helps us reuse the code. We don't have to redefine those methods over and over again. If we want to use properties and methods of a class, we can just extend it multiple and create multiple objects, and all of those uh, inherited classes will have the same properties and methods. If we make a change at one place, we don't have to keep making it in all the classes. Anything that extends it will automatically have that change. So it basically reduces the development time because reusability requires less memory, less execution time, redundancy can be minimized, etc. Flexibility, inheritance makes code flexible to change, as you'll only adjust in one place and the rest of the code will work smoothly. Overriding, with the help of inheritance, you can override method of a base class and make it do something else. Data hiding, the base class and the inheritance decide which data to be kept private, such that the derived class will not be able to alter it. Okay, so there are different types of inheritance. Single inheritance, multi-level inheritance, and hierarchical inheritance. So in single level inheritance, one class inherits another class. In multi-level, one class inherits another class, and that class inherited by another class. It's like a chain. In hierarchical inheritance, multiple classes are inheriting the same class. Now in Java, we don't have the multiple inheritance supported by default, which is why the interfaces helps us achieve that, and we'll talk about that a little later. This is an example of a single level inheritance. You use the keyword extends, and then you go ahead and instantiate the class that has been extended, and then you have access to not only the one that's extended, which is the child class, but also the parent class method. Okay, you have multi-level inheritance example. Dog extends animal, baby dog extends dog, and then when you go to instantiate the last one, then you'll have access to everything that's above in that hierarchy. Okay, hierarchical inheritance example. Dog and cat inherit the same class, which is animal. So here, this class will have access to meow and eat, but not bark. Similarly, dog will have access to bark, but not meow. And will have access to eat also. Member access in inheritance. Often an instance variable of a class will be declared private to prevent its unauthorized use or tampering. Inheriting a class does not overrule the private access restrictions. Even though a subclass includes all of the members of its superclass, it cannot access those members of the superclass that have been declared private unless you use getters and setters. What is polymorphism and its advantages? Well, poly means many, and morphism means forms. So an object that can take many forms. So let's talk about that. It allows one interface to be used for a general class of actions. The polymorphism principle is implemented in Java programming with the methods of overloading and overriding. Overloading allows us to use the same method each time with a different signature, different parameters. Overriding allows us to override a method, which means declaring the same method in the child class as it has in the parent class, but make it do something else. So overriding works together with inheritance to enable code reuse of existing class without needing to recompile. It tends to reduce the pairing of multiple functionalities and allows programmers to reuse, evaluate, execute the program modules forms written once. So what are the advantages? Advantages is that it tends to reduce the pairing of multiple functionalities, and allows the programmers to reuse, evaluate, and execute the program modules forms written once. Types of polymorphisms, you have static and dynamic. In static, you use overloading is achieved by overloading, and dynamic is achieved by overriding. So static polymorphism is the linking of a function with an object during compile time. It is achieved through the method of overloading. In overloading, methods use the same name but different parameters. Dynamic polymorphism, in this compiler doesn't determine the method to be executed, is the JVM that performs the process at runtime, achieved through overriding. So static polymorphism is linking of a function with an object during compile time. And here, compiler doesn't determine the method to be executed. It's the JVM that performs the process. This is an example of overloading. Same function being called each time with a different parameter, different number of parameters. That's overloading. In overriding, we can see a single method draw can be used to draw the different shapes like triangle, circle, and rectangle. So here we can observe the name of the function is the same, but the functionality is different each time. And this type of polymorphism is also known as overriding. Use of super keyword. I think this was one of the questions in last year's exam which Somaya had shared. So in case if we want to access a parents class method which has the same name as the method defined in the child class. For example, here we have animal sound in the parent class, and we also have animal sound in the child class. If you want to access the parent one, how will the system know? We can use super and then dot. So super keyword refers to a super class parent object. It is used to call superclass methods and to access superclass parent constructor. It is used to eliminate the confusion between superclasses and subclasses that have the same method with the same name. Okay, access modifiers in Java. There are 4 types of access modifiers. We have private, public, default, and protected. If you declare something private, it is only available within that class. It's not available outside unless you use getters and setters. If you declare something public, it's available everywhere within the package, outside the package, within the class, outside the class. If you declare something as, okay, so private is done default, the access level of the default modifier is only within the package and cannot be accessed from outside the package. If you do not specify any access level, it will be default. Protected, the access level of protected modifier is within the package and outside the package through a child class. Okay, so public we already discussed. So these are the 2 ones to take care of. So default is only within the package, not outside. Protected is within the package and outside, but through a child class. Use of constructor with the help of a program. This is your constructor called main, same name as the class name. Just printing something and assigning a variable. And constructor is invoked while creating an object of the main class. So when you create an object of the main class, this constructor is automatically invoked. So constructor is used to initialize the objects at the time of creation. Constructors have the same name as the name of their class. Once a constructor is defined and used for object creation, it automatically called and the memory is allocated before new operation completes. Main method is used as an entry point for a Java program. This is the method which is invoked by JVM to execute the program. Every class has a constructor. Even if you don't declare one explicitly, compiler will add a default one. Constructors allow to create an instance of a class, whereas the main method merely allows for a potential entry point to execute the program. The order of execution, every class has its own constructor. So the execution of constructor starts at the object initialization. In a single inheritance, the constructor of a base class is executed first, which means the parent class. In multi-level inheritance, the upper class constructors are executed when instances of a bottommost child are created. So it goes from the top to bottom. Calling same class constructor using this keyword, a class can have multiple constructor, and you can use this to access the constructor. Calling superclass constructor using super keyword, a child constructor or method can access the base class constructor or method using the super keyword. Use of static method in Java. So static methods are those methods which are declared as static with a static keyword. And in order for you to access the static methods, you don't really need to instantiate the class. You don't need to create an object. You can access them in, for example, in a child class without having to instantiate the object. Okay, static keyword is used to construct the method that will exist regardless of whether or not an instance of a class are generated. Any method that uses static keyword is referred to as static method. They have access to the class variables without using the class object instance. So static method has access to, for example, college here. Advantages and disadvantages of garbage collection. In this process, Java frees the dynamically allocated memory, which is no longer referenced. It can make programmers more productive. It ensures program integrity. It adds overhead to the system, which adversely affects the program's performance. The programmers in garbage collected environment have less control over the scheduling of the CPU time, and it is devoted to freely objects that are no longer needed. Use the final keyword. So final keyword, you can think of it like creating constants. If you declare something as final inside of a class, the value of that cannot be changed or overridden. Finalize method are generally called for cleanup activities, and it is called before the object is deleted, before destroying the object. So it is called by the garbage collector before destroying the object from the memory. Finalize method is called by default for every object before its deletion. This method helps garbage collectors to close all resources used by the object and helps JVM in memory optimization. So we have this finalize method, and it will get called at the end during the destroying of the object. Features of Java. Somebody else to read it. I'm tired. Rajan, are you there?
Yes, I'm here.
Can you read it, please?
Sure. Features of Java. It's based on object-oriented programming concept.
Mm-hmm.
Everything in Java is an object.
Mm-hmm.
Object promotes understanding of real-world problems in a natural way. They provide practical basis for implementation of a design of the system. Simple and secure. Java is easy to understand and write, having user-friendly syntax. We can develop a virus-free system using Java programming language because it has no explicit line pointer. It runs inside a virtual machine sandbox. Portable. Java facilitates you to carry the Java bytecode to any platform. Within the help of the bytecode, you can run the Java program on any computer virtually.
Right.
Java provides three types of portability. Source code portability, like CPU architecture portability, and OS GUI, graphical user interface. Robust. Java provides an automatic garbage collector that runs on the virtual machine and destroys the objects which are not being used in the program anymore.
Okay.
Then multi-threaded. Java runtime system comes with an elegant solution for multi-process synchronization that enables you to construct smoothly running interactive system. Architectural neutrals. Java Virtual Machine was designed to write once, run anywhere, anytime. Interrupted and high performance. Java bytecode can be translated into native machine code using the just-in-time compiler, which is faster than the standard JVM. It also facilitates running one time and catching the result for future.
Okay. So it's just an example of your file that is run by Java compiler, which creates a dot class bytecode. And as you can see that the different types of JVM, one for Windows, Linux, or Mac, and it can run on all of them without any issues. And that's why it's called architecture neutral, because the same code can run on multiple machines, JVM.
Yeah.
Okay, one.
Okay. Uh, Distributed. After compiling the Java program on one machine, it can be transferred on another machine to execute because of bytecode facility. It supports a remove method invocation, which enable a program to invoke method across the network. Dynamic. Java program carries substantial amount of runtime type information that is used to verify and resolve the access to object at a runtime. This enables to link code safely and exponentially dynamically. Using class loader, you can also hold a new already compiled class at runtime in a standard language supported way.
Okay.
Java development environment and tools. You can write, compile, and edit Java programs in two ways: command line environment and integrated development environment, the IDE. Uh, NetBeans and Eclipse are two free and popular IDE for developing Java programs. Components to Java development environment. The key component of Java development programs are JDK, Java Development Kit, JRE, Java Runtime Environment, JVM, Java Virtual Machine, Just-in-Time Compiler. The component JDK, JRE interact with each other to create a sustainable runtime environment that enable the seamless execution of Java-based application in virtually any operating system.
So that's your JDK that's available in for all the Java programs, development tools. Inside of this, you have the library, and then inside of this, you have JVM, which has GIT. Go on.
Okay, JDK, every module of a Java comes under JDK. JRE is Java class library. JVM is an instance of JRE while executing the Java program. It is a runtime interpreter.
Okay.
JIT is a part of a JVM that is used to speed up the execution time. It does that by compiling the parts of a bytecode that have similar functionality simultaneously.
Okay. So every module has JDK, comes under JDK. JRE is a Java
Java
class
library.
library. JVM is an instance of JRE, and it's a runtime interpreter. And JIT is a part of JVM, which is used for speeding up the execution time. Okay.
JDK, Java Development Kit. It is a software development environment which is used to develop Java application. It contains JRE, Java Runtime Environment, along with development tools. JDK contains private Java Virtual Machine (JVM) and a few other resources like interpreter, loader, Java compiler, architecture, jar files, and Java doc for the document generator to complete the development of Java application. It is a software layer that runs on top of the computer operating system software. It provides the class library and other required resources to run on a specific Java program. GRE runtime architecture generally uses class loader. Dynamically load all the necessary classes to run a program. It also automates the loading of classes as per requirement, so it can also be effective utilize the memory. Bytecode verifier checks the format and accuracy of a Java code before it passes to the interpreter. Interpreter helps to run the Java program natively on the Flying machine.
Okay.
Yeah. Just-in-time compiler (JVM). Just-in-time, an integral part of a Java virtual machine and a garbage collector. Just-in-time (JIT) can compile the Java code into machine code, which can significantly improve the performance of a Java application. Just-in-time usually compiles the code of a requirement to JVM once method execution across a certain limit machine code. The program written in Java are compiled into machine language, but it is a machine language for computer that does not really exist. That is what we call a virtual computer, and it is also known as Java Virtual Machine. The machine language for JVM is known as a Java bytecode. This code enables us to run the program on any computer.
Okay. So this is the flow of the Java program execution. First, we create a file, whatever that name of the file is .java. That's your source code file. That is compiled by the Java compiler. It generates the .class file using the library code, and that is executed by the JVM, Java Virtual Machine, which then finally produces the output of the program. That's the flow of the execution.
Yeah,
Okay, data types. This
yeah.
is important.
Primitive data type and non-primitive data type. Yeah, primitive data type. Primitive data type includes a boolean, char, byte, short, int, long, float, and double.
Okay.
Yeah. Non-primitive data type. Non-primitive data type includes classes, interface, and arrays.
Okay.
Okay, this is a breakdown like its default size and default value. Boolean it is true or false, right? So it is a
Hmm.
1 byte character. It have one character will have 2 byte. Byte it will be like a 1 byte. Short will be 2 byte. Int will be 4 byte. Long 8 byte. Float 4 byte and double 8 byte.
Okay. What are
Non-primitive
classes?
data type
Classes are
classes.
the blueprint which are used to create the objects, such as properties and methods. And
Yeah.
interfaces are basically the blueprint of the classes. It has static constants and abstract methods. It is used to achieve abstraction. By interface, we can support the functionality of multiple inheritance and also achieve loose coupling. Okay, go on.
Okay. Arrays. Array is an object which contains element of the similar data type. Additionally, the element of an array are stored in a contiguous memory location.
Okay.
We can store only the fixed size of element in array. It does not grow its size at runtime.
Okay.
Single dimensional array. Okay. A list of variable of a similar the same data type. We can access the values using index.
Hmm.
Multi-dimensional array is an array of arrays that uses more than one indexes to access the array element.
Okay.
Difference between static and dynamic array. Static arrays are declared before runtime and are assigned value or while writing the code. The static arrays are allocated a memory at the compile time. Dynamic arrays is declared while writing the code and memory is allocated at the runtime. Int
Hmm.
arrays declared int are 1, 2, 3, 4, and in dynamic arrays we use pointer like int pointer array new int 3. The size of static array is fixed. The dynamic array is a variable size. It grows automatically when we try to insert the element if there is no more space left for the new element. It is located at a stacked memory space. The memory is located from the heap.
Okay. This is a program to print the sum of the array. We are declaring an integer type array, and then we are assigning its value 1, 2, 3, 4, 5. We are holding the sum value as 0, looping through this entire array, and just adding each of these value in the sum, and then finally printing the sum. Unicode. Yeah, go on.
Unicode, yeah. Of 16-bit character encoding standard. Oh no.
Yeah, yeah, fine. Okay, 16-bit character encoding standard is capable of representing almost every character of well-known languages of the world. For Unicode, there were multiple standards to represent characters in Unicode like ASCII, ISO, KOI, etc. Some characters were using single byte, some two to support multinational application codes, and even same code may represent a different character in one language and may represent other characters in another language. So, to overcome above shortcomings, the Unicode system was developed where each character is represented by 2 bytes. As Java was developed, multilingual languages, it adopted the Unicode system. So the lowest value represented by backslash u 4 times 0, and the highest value is represented by backslash u 4 times f. Okay. What are variables? Variable is the name of the reserved area allocated in the memory whose values cannot be changed. Different types of variables are local variables, which basically are defined within the body of a method, and the outside world in the class doesn't have access to that. And then you have instance variables, which are the variables defined within the class, but they are not inside of the body of the method. A local variable cannot be defined as with a static keyword, but the instance variable can. This is your instance variable. Static variable, variable declared as static. You can use that variable without instantiation of the class, without even creating the object. And the same value is shared between multiple classes. Create a single copy of static variable and share it among all the instances of the class. Memory allocation of static variables happens only once when the class is loading and loaded in the memory. Okay. So that's all for the recap. Now we'll move on to the new topic. Let's see where we start. Done interface, extending, yeah, declaring and implementing the interface, and this is where we need to. We did the threads also, I think, yesterday. Yeah, string builder class. This is where we need to start. So Maya, can you read this?
Yeah. String builder class. String builder in Java is a class used to create a mutable, or in other words, a modifiable succession of characters.
Mm-hmm.
Like string buffer, the string builder class is an alternative to the Java strings class, as the strings class provides an immutable succession of characters. However, there is one significant difference between string buffer and string builder, and it is that the latter is non-synchronized.
Mm-hmm.
It means that the string builder in Java is a more suited choice while working with a single thread, as it will be quicker than string buffer.
Okay, these are the string builder methods. You have append, used to append the specified string with the string. You have insert, used to insert the specified string with the string at a specific position. You have replace the string from a specified start and end index. You have delete the string from a specified start and end index. You can reverse the string using reverse method. Capacity returns the current capacity. Ensure capacity ensures the capacity at least equal to the given minimum. Char at returns the character at a specified position. Length will give you total number of characters. Substring will be used to return the substring from specified begin index, etc. Okay, go on.
Java's string buffer class is used to create mutable or modifiable string objects.
Okay, so what's the difference between the string buffer is used to create mutable, which means modifiable string objects, and this is used to create mutable, in other words, modifiable succession of characters. Okay, succession of characters. And this is string object. So those are character and this is object. Okay. Go on.
The string buffer class in Java is the same as string class except that it is mutable. That is, it can be changed.
Okay. So these are the methods: append, insert, replace, delete, reverse capacity, ensure capacity, char at length, substring, substring. Okay. String class versus string buffer class. Yeah, this is a question in the assignment. And I think, so Maya, where did you get that question paper from?
From IGNOU's website,
So
we
does
search
that
for
mean
previous year question papers.
PGDCA new was introduced last year in December, or maybe in the first or January or something?
It was introduced in January 2021, but there are no papers for June, only
Oh,
December.
okay. Did you notice that in the question paper they have given most of the questions from assignment as well as from the textbook itself?
Yeah,
Yeah, like when I was studying the database indexing is nowhere in the assignment, but it's there in the textbook.
yeah.
Yeah. Okay, cool. So let's go with this one. Please read this.
The string class is immutable. The string buffer class is mutable. String is slow and consumes more memory when we concatenate too many strings because every time it creates a new instance.
Mhm.
String buffer is fast and consumes less memory when we concatenate the strings.
Okay.
String class overrides the equals methods of object class, so you can compare the contents of two strings by equals method. String buffer class doesn't override the equals method of object class.
Okay.
String class is slower while performing concatenation operation. A string buffer class is faster while performing concatenation operation. String class uses string constant pool. String buffer uses heap memory.
Okay. Okay. Let's do IO stream. What are Java IO?
Java I/O input and output is used to process the input and produce the output. Java uses the concept of a stream to make I/O operation fast. The java.io package contains all the classes required for input and output operations.
Okay.
We can perform file handling in Java by Java I/O API. A Java file class. The file class is an abstract representation of file and directory path name. A path name can be either absolute or relative. The file class has several methods for working with directories and files, such as creating new directories or files, deleting and renaming directories or files, listing the contents of a directory, etc.
So file. Let's go back 1 second. So Java IO is used to process input and produce output. Okay. Uses concept of a stream for the output operation, and the package in which all the classes are available is called java.io. Let's just kind of highlight stuff so make it easier to read. Process the input and produce the output. Okay. Uses the concept of stream. This is java.io package. Perform file handling. Can perform file handling. Okay. And the next one was file class is an abstract representation of a file and directory path name, which means maybe that file has a lot of the information and kind of abstracting just the main things that we need. So it's an abstract representation of file and directory path name. Okay. File class have several methods for working with directories and files such as creating new directories of file, deleting all of that stuff, listing content. Okay. So it has the main key point is it has several methods. for several methods for working with directories and files. Okay. So it has different methods like create temp file. It creates an empty file in a default temporary file directory. Create new file automatically creates a new and empty file name by its abstract path name if and only if the file with this name doesn't exist yet. Can write, it tests whether the application can modify the file denoted by this abstract path name dot string. Can execute, if it can execute or not. Can read, if it's readable or not. Is absolute, test whether this abstract path name is absolute. Is directory, test whether file denoted by this abstract path name is a directory. So whatever you're going to pass here, the path is going to check if that's a directory or not. And this is going to check if it's an absolute path or not. Okay, is file. So is file is going to test whether the file denoted by the abstract path name is the normal file. Get name returns the name of the file or the directory. Get parent returns the path name string of an abstract path name's parent. ToPath returns java.nio file path object. ToURI constructs the file URI that represents the abstract path name. List files returns an array of abstract path names denoting the files in a directory denoted by abstract path name. Okay. Okay, go on.
The auto-closable, closable, and flushable interfaces. There are three
Okay.
interfaces that are quite important to the stream classes. Two are closable and flushable. They are defined in java.io and were added by JDK5. The third, auto-closable, was added by JDK7. It is packaged in java.lang.
Okay.
Auto-closable provides support for the try with resources statement, which automates the process of closing a resource. Only objects of classes that implement auto-closable can be managed by try with resources. It defines only the close method. Objects of a class that implement closable can be closed. Closable extends auto-closable. Therefore, any class that implements closable also implements auto-closable. It also defines the close method. Objects of a class that implement flushable can force buffered output to be written to the stream to which the object is attached. It defines the flush method.
Okay, so there are three interfaces, okay, to the stream classes. Important to stream classes. Two are closable and flusher. They define in java.io, added by JDK5, and this is defined in java.lang. Autoclosure provides support for try with resource statement. Automates the process of closing a resource. Only object of classes that implements autoclosable can manage with try and resources. It defines the close method. Object class that implements closable can be closed. Objects of class that implements, okay. Objects of class that implements flushable can force buffered output to be written in the stream. Okay. Let's move on to this one. Samaya.
Java IO exception. IO exception means any input-output exception that can occur while reading a file or writing into a file, basically accessing the file system.
Okay.
Java IO exception extends the Java exception class. To get the serializable form, the interface serializable is implemented by the class that extends IO exception. This is useful when you have custom exception classes for your project. For the program to exit gracefully in an exception case, we should surround it using a try-catch block. This also means that IO exception is a checked exception.
Okay, so checked exception which will get executed, the unchecked will not get executed. So we have a try method. We instantiate the file input stream class, pass the file name of a file, then hold it inside of a variable called FIS with the type file input stream. We print checking if the file is there. So this is going to check if the file is there, and if it's not there, then it's going to cache that exception. And then we already know that this object has a method called get message, which is going to print whatever message, the exception message that we have. Okay, so that's how the exception is handled with the Java input output. Okay, go on.
Java provides IO streams to read and write data. A stream means continuous flow of data. A stream represents an input source or an output destination, which could be a file, IO device, other program, etc.
So you might have heard about different ads like streaming now on Netflix and all of those things. So what happens is when the data is really big, you don't want to uh, basically kill the user's internet by downloading everything. Like if you're going to watch a movie which is 3 hours long, imagine how the size of that particular movie will be. So if we load everything, it's going to eat up his internet, and he might not even watch that movie. He might just watch just few seconds of the movie and might not like it and want to switch to something else. That's where the streaming comes in picture. So streaming means continuous flow of the data, and a certain amount of data is flown rather than flowing everything. So he watches that. Once he reaches a position, another set of data is flowed. So it's like a stream. So whatever stream means, literally, that's what you're talking about. It's like a stream of the data. Okay, carry on.
Java encapsulates stream under java.io package. Java defines two types of streams. Byte stream. It provides a convenient means for handling input and output of byte. Character stream. It provides a convenient means for handling input and output of characters. Character stream uses Unicode and therefore can be internationalized.
Okay. This is important. This was in assignment.
Java IOStream and different stream classes. Java provides IOStreams to read and write
Wait, wait,
data.
wait, wait, wait,
This is the
wait,
same.
wait. I think it's repeated. 1 second. Why is it repeated? And different stream classes. 1 second. Java stream, Java IO stream, and different stream classes. Yeah, I think the first one needs to be deleted, I guess. Yeah, first one needs to be deleted. Repetition. It looks like this is important. We already covered that. What is Java IO stream and different stream classes? It's a byte stream class and character stream class. Now this is an explanation. So the question will be something like, what is a Java IO stream, and name and describe the Java stream classes. So this is the information about what a Java stream is, and these are the classes, and then details of that are here. Go on.
Byte stream classes. Byte stream is defined by using two abstract classes at the top of hierarchy. They are input stream and output stream.
Okay.
These two abstract classes have several concrete classes that handle various devices such as disk files, network connection, etc. Some byte stream classes are buffered input stream, buffered output stream, data input stream, data output stream. These classes define several key methods. Two most important are read, reads byte of data, write, writes byte of data.
Okay, so we talked about that there are different types of stream classes in Java IO stream. One is byte stream class, and second is character stream class. So now we're talking about the byte stream classes, which basically has two abstract classes: input stream and output stream, and that's what we're talking about here. with these two important methods. Okay, go on.
Character stream classes. Character stream is also defined by using two abstract classes at the top of a hierarchy. They are reader and writer.
Hmm.
These two abstract classes have several concrete classes that handle Unicode characters. Some character stream classes are buffered reader, buffered writer, file reader, file writer. Read method is used with buffered reader object to read characters. As this function returns integer type value we need to use typecasting to convert it into char type.
Okay, so program to save the given data in a file. So here we have a library called java.io which has input and output stream. We have multiple stream classes available like buffered input stream, buffered output stream, file output stream, IO exception. This is all what we spoke about. We can create our own class with our own custom name. In this case, buffered input stream example. Inside of the main function, we have to use throws exception. Then we instantiate the buffer input stream. We pass the system.in, and then we store inside of an object, basically create an object of this type. Then we instantiate the byte. So we create an object of the byte type, okay, which will be an array. Then we print enter your data. This is where the user will enter the data, and this is going to read it from the keyboard. Then we're going to output that into a text. So the job of this basically is that we'll ask the user that enter your data, hello world, or whatever you want to enter. We're going to grab that data and put that into a file and create that file if it doesn't already exist and put that data there. So that's the job of that, to save the given data in the file. So here we read it using the read method of the input stream. We read the data, and then we use the file output stream. And the job of this is basically to output the data into that file. Okay, so we have to provide the path to that file where we want to save the data. Then next is we use buffered output stream like the way we use buffered input stream. And here we pass system.in, but here we'll pass out because we need to output that. And then we use the method of this object output stream called write and pass bytes into this because that's what the user passed it. Okay, so this is going to write that into this hello.txt, and then finally flush, and then print it the message saying that data saved in the file. I've tried this, it works, and I can show you if you want. It's called IntelliJ. Name of the class is buffered input stream example. Yeah, this one. So you can see this is the same class, same code that we've just looked at. I'm just going to run it. Something went wrong. Yeah, I guess I don't have these packages or something. 1 second. What's happening? Remove this. Yeah, enter your data. So I'll say hello world. Hit enter. You see that he created hello.txt here and it put hello world. Null is coming from here. I don't know where it's coming from, but yeah, main thing is that we got the hello world and created that file. Okay. Cool. I think we'll pause today. And then, Sumaya, you have a session tomorrow, right? At 5 o'clock?
Yeah, 5 or 6?
Yeah. 5 is yours, 6 is what we take generally. So
Okay,
within 5 and 6, you can explain. You can basically try to solve those questions and explain.
okay,
Okay, thanks then. Bye bye.
bye.